We're going to take a look at an ionic bond by using the Lewis dot diagram in order to model this process. We're going to take a look at this process using beryllium and fluorine as examples. So the first thing that we need to do is draw a Lewis dot diagram for each atom. Notice I have a little periodic table here. Beryllium is right there and fluorine is over on this side. So beryllium is going to be in the 1, 2 second family. So it will have 2 valence electrons. So I'm going to draw its symbol with 2 valence electrons as dots around it. I'll do the same thing with fluorine. Fluorine is in the 1, 2, 3, 4, 5, 6, 7th family, so it needs 7 valence electrons around it. 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so remember, to become stable, atoms must gain electrons until they have 8 or lose until they have 0 electrons. So fluorine has 7. It's super close to having 8 electrons. It just needs 1. There's 1 empty space for 1 more electron that fluorine can hold until it has a completed octet or 8 electrons. Beryllium, on the other hand, is really close to having 0. So beryllium is going to give its electrons up until it has 0 electrons in its second energy level, which means then its first energy level will then be full. So the electrons must go somewhere. Beryllium's not going to give its electrons up to the magical cloud that is just floating around, right? In the similar way, fluorine's not going to gain an electron out of nowhere. It has to come from somewhere. So we're going to use electrons from one atom to fill in the empty space for the other atom. So beryllium will give one of its electrons up to fluorine. That means that fluorine now has all 8 electrons that it needs, and beryllium has gotten rid of one of its electrons. So fluorine now, chana, is full. It has 8 electrons. It's very happy. On the other hand, beryllium has 1 more electron it must get rid of. So when we're in this situation, we might have to add atoms since we have electrons that still need a place to go. So we'll add an additional fluorine atom over here. 1, 2, 3, 4, 5, 6, 7 electrons, just like the last one, with 1 empty spot. Beryllium will give its electron up to fluorine. Fluorine will take it, and beryllium will give it up. So fluorine now has 8 electrons, very happy, and beryllium, chana, also has gotten rid of all of its electrons. So we'll pause here and just indicate now what we have. Look, since fluorine has gained an extra electron, it is now fluorine -1. So I can indicate that I don't have the fluorine atom anymore. I have the fluorine ion. Same way with beryllium. Beryllium also has gotten rid of its 2 electrons. We can actually erase these to make that a little bit more clearer. And since beryllium has gotten rid of its 2 electrons, it is going to be a 2+. When it gets rid of 2 negative things, it becomes a 2+. The other thing that modeling ionic bonding with Lewis dot diagrams allows us to do is write a formula. So the formula for this ionic compound is going to contain both beryllium and fluorine, but this model shows us how many of each we need. So beryllium, we only needed 1 beryllium to make a complete ionic compound. So I am going to indicate that I just have 1 beryllium with that subscript. For the 1, you can either write the subscript or you can leave it off. And then fluorine was also used to make this ionic compound, and I used 1, 2 fluorines. So I'm going to write a subscript 2 behind the F to show that I needed 2 fluorines to complete this ionic compound. And that is the formula for our ionic compound.